Good morning, everyone. I hope you are having a great time in the conference as well as in London. London is a very special place for me. I come from New York, which is 5 hours away from London, and my hometown is in New Delhi, which is again 5 hours from here. So it's the center of my world. So every time I'm making the trips between where I live and where I come from, I make a stopover in London, and either direction, I find it very difficult to leave this place. Having said that, I think I have been chosen to speak on this topic on how to create a business case for big data, not because I'm a big data expert, but it's because I'm not an expert. And the way I see big data and any other tool or technology that needs to be implemented for analytics is a very layman view of how we see technology from a business or an analytics perspective. So my first slide, I'm trying to set the tone here. In 1943, most of you know someone said this, that there might be need only for 5 computers. And whether the IBM chairman really said that or not is still questionable. But let's believe so. On the same tone, I would like to start with a number, 65,000 rows. I think most of you present in the room can relate with that number. I think in 1995, when Microsoft Excel launched the product, that's what they thought. They thought that 65,000 rows will be enough to do all the analytics, to deliver all the reports. And today we are here talking about billions and billions of rows and terabytes and petabytes, and I don't know, all the suffixes. We are running out of suffixes on the bytes to explain how many rows of data we need. Just to take it down a bit further, year 2000, I got my first laptop when I was in college. It had 128 megabytes of RAM, disk space of 4 gigabytes, and I had 2 partitions on it. One had Linux and one had Windows. And I still had a lot of disk space free, which is truly unbelievable today, because if you take a memory card of 4 GB on your camera and try to go on a vacation, I'm pretty sure you will be found shopping for an SD card. Poor Megabyte. What happened to the mega in the Megabyte? When you talk about Megabyte today, people think it's too small. So probably the prefix has lost its value. So the reason I am talking about these things is because people who come from the analytics background or people who see data from a business perspective have seen this journey of how data has evolved in size, in shape, in frequency. In these terms are very, very small, very, very simplistic. And that's how we have seen data evolve. In 2007, Microsoft Excel said it can now handle 1 million rows. And I know a lot of you are not impressed, because a lot of people here are data geeks and experts in the industry. And 1 million is too less in today's age. So the point I'm trying to make here is we have seen so much development in the size of data in the last 10 or 12 years that when we talk about these millions and trillions of rows, we are still talking to the same people. We are talking to an audience who doesn't understand technology, who doesn't understand database, they do not understand data warehouses. So when we go to a C-level audience, this is the journey they have come through, and this is the perspective that they carry. Today, obviously, we are talking that even terabytes of information will not be sufficient. Even the RDBMSs like Oracle and Teradata will not be enough. We are talking about appliances today. So there are people who come to me and say, do you want a Green Plum? Do you want a Netezza? Do you want an Aster Data? And I get flabbergasted because I have not even heard these terms, leave alone calling it an appliance. So the way the data has evolved over a period of years, first there was a concept of data entry. So it's not just that data has grown in size, but also how we deal with data has changed. We started with something called data entry. There used to be jobs 10 years back where people used to enter data all day, and that's how data was ingested. Over a period of time, we started putting some structures around the data, and we started a process of data capture, and that's how we started feeding it into two-dimensional tables in RDBMSs. But today, we are not talking about data capture, we are not talking about data entry. We are saying about capturing conversations, we are talking about capturing everything that is happening in web, everything that is happening in social, take it as it comes out from different channels. So that's a very transformational thing because everything is very unstructured. And how to make sense of that data is a very, very difficult task. And that's where technology comes into play, and that's why big data comes into play on how to mine that enormous amount of data, not only in terms of volume, but also in terms of that unstructure, how to make sense out of that unstructure, and then how to translate that into some actionable insights. That's a very difficult job. And that's why we talk about big data, and that's why we talk about big data as such a transformational technology. I think from a business perspective, when I look at big data, I don't know whether I would like to call it big data, because the transformation that is happening today in terms of evolution of data is very similar to what happened when the microscope was invented. So we are not really looking at big volume of data, but big data is giving the business an ability to go down into the grain and to be able to monitor every event, to be able to monitor every customer interaction, every touch point, and be able to optimize our strategies, to be able to optimize our analytics. So I see it as microdata. It's almost like microbiology, it's almost like subatomic physics, it's almost like splitting the atom and going into that grain of data which will tell you how the world works. It may still not, but that's what we would like to think. Having said that, some of the early adopters of big data, as you know, have been in retail. There have been market mix modeling, there has been multi-touch attribution. In fraud, there has been a big adoption in terms of detecting all the events that happen, flagging them as triggers, and then optimizing the risk and fraud strategies, optimizing the authorization strategies. being used in energy, logistics, healthcare, and you name it all. But I think one key area where big data is making an impact is in digital marketing. It's in digital analytics, because that's where the volume of data is really exploding. Not because we are able to capture a lot of data, but the consumers are actually becoming the producers of data. There are so many devices, there are so many channels where data is being created, and we want to ingest all of it. So digital marketing or digital channels will really transform the way we capture data, will transform the way we look at the size of data. We are talking about real-time offers. So a person goes to a website, clicks on an ad, then goes to another page, and we are trying to optimize what ad that person will see depending on the behavior of the click stream, which has happened in the last 60 or 120 seconds. We are not only talking about optimizing it based on that data, but we are also talking about ingesting third-party data. We are saying, let's see how this guy has been going on the web and what kind of websites this person has been visiting, and based on that intent, based on that purchase intent, based on that browsing behavior, let's show him a particular offer and try to optimize it on value in terms of acquisition. So what I've tried to do here is, from my perspective, I have been a key decision maker in implementing a lot of tools, a lot of analytics infrastructure, a lot of technologies that enable analytics, that support analytics. And I've tried to boil it down into 10 key points. And those are the points probably, from an IT perspective or from a data warehousing team or from technology guys. I see if technology people focus on these 10 points, probably, it might help marry the perspective of how an analytics manager looks at technology versus how an IT manager looks at it. So how do you create a business case for a technology like big data? I think the first point I would like to state here is that you should never try to create a business case. So there should be a valid business case. So don't try to create a business case. I think don't try to force fit a solution or a technology or a tool just because it exists. So you have to really do a very good research and see whether there is a business case and what is the scope of that business case and what will it solve for, and make that tool or technology a supporting infrastructure and not really the end in itself. Minimize jargon. Here is an example of what some technology guys come to me and that's what they talk about. We'll have a server with 16 blades, 10 nodes, 15 racks, and it will be a commodity server, commodity hardware, and it will have horsepower. So I think there is an obsession in the IT world about mechanical engineering somehow. So most of these terms are used in mechanical engineering, and I don't know how they come in the IT world when we talk about implementing servers or implementing new technology or implementing new databases. So if a node is a server, let's call it a server when we are trying to create a business case for it. If a blade is a processor, then let's call it a processor, so that it makes it easy for someone from business to understand. I think that would be very important. Business cares about business metrics. So often when we talk about big data or any other tool, we talk about processing power, we talk about time, we talk about volumes of data, we talk about petabytes, exabytes. But the business doesn't really care about churning huge amount of data, doing the processing in milliseconds, or having a lot of processing power and performance. What the business really cares about is metrics. So when you are trying to create a business case for technology solutions like big data, I think you should be talking about the business metrics. What will the tool enable? Is it dollars? Will you be reducing the risk by some margin? Will the acquisition go up by X number of percentage? So that's what we should be talking about. We should not really be talking about the technology or the metrics that we use in technology, but we should be, when we are trying to create a business case, then we should be talking about the metrics that the business is interested in and how that will get enabled by the use of that technology. Talk about simplicity, not complexity. So we often talk about how complex algorithms we can churn. We talk about NPath, how it can do parallel threads and a very complex lookup and a stacking logic. But I think what we should be talking about is how it will simplify a business process, how it will simplify a business problem, how it will make life easy and simple for a strategy to be implemented, how it will make the data more actionable, how it will help deployment of a strategy. I think that's what we should be talking about. Talk about the smaller grain and not the big size. So that's something I was talking about earlier, that when I look at big data, I look at big data as a microdata, where we are going down into the grain and enabling looking at event level data, looking at customer level data, or looking at streaming data, looking at data that is coming from the live sensors, how we are making it real time. So let's talk about how fine we are going and how it will help the business, how it will help the strategy, how it will fine-tune the analytics that we deliver today. Think about experience, not about a transaction. So we are not solving for a transaction. So when we look at implementing any technology or a solution or a tool, it should not be solving for one particular business case. It should not be an island in itself. So when we are putting in place a tool or a technology, it should be talking to different tools. It should be talking to different deployment channels. And we should be thinking about a holistic customer experience. So we should not be solving for someone visiting a website, but we should be solving for someone visiting a website and then going to a branch and then going into a mobile app and being able to unify the experience, being able to make it consistent across these touch points for the customer, being able to make it consistent not as a customer, but if you are a brand, then making sure that as a brand you are giving the same message across different touch points to an individual. Architecture. Whenever we are creating any solution, any technology, it should not be isolated. It should be talking to the existing ecosystem. It should almost be like a plug-in model. We should not come up with solutions where we have to start from scratch. We have to do a lot of customization and build everything right from bottom up. So it should be able to integrate into the existing architecture or infrastructure. I think this is a very important part that is often ignored, not only in the IT world or in the technology world, but also in the analytics world. When we started analytics like 10 or 15 years back, I think the leadership understood the vision, and we knew why we are doing a particular analysis, why we are doing a predictive model, why we are doing some statistical algorithm. But we were not able to communicate it to the data analyst or the data scientist. So I think it's very important that somebody who is making his or her hands dirty with the data understands the vision of the business. So that's very, very important. I think in the analytics world, we have been able to do that. The people who deal with the data, who build the models, who build the segments, who build the strategies, now do understand why the strategies are being created, where they will get implemented, how they will affect the bottom line or the top line. But I think there is still a gap between technology teams and the business teams in understanding why a certain tool or a technology is being implemented. And I'm not talking at the leadership level, but actual developers, actual programmers who are building that tool, they should understand that. I think one big question that keeps coming up when we talk about big data implementations is the skill set. Do we need rocket scientists if we go with big data, if we sign up for it? Are there any caveats in terms of training? I may purchase an appliance today, but do I have the skill set in the organization to be able to make it sustainable? Will I be able to carry it forward on my own? I think that question keeps on coming with all the appliance solutions. We still do not have very good answers, but probably if we are trying to create a business case, then we need to solve for it. We need to have an answer for it. I'm not saying there is no answer for it, but probably we need to look at it. Last but not the least, set expectations. Talk about limitations. Don't talk about the good stuff, but also talk about constraints, because be honest whenever you are presenting a business case. So everybody understands that every tool has limitations, every technology has limitations, every technique has limitations. So talking about them actually makes your idea or your tool or technology more feasible. It doesn't really impact it negatively. So talk about the limitations of the tool, be realistic, be practical, and set expectations that you can exceed. Don't set expectations where you'll fall short. Here is a recap of the 10 points that I talked about. Have a strong and a well-researched business case, minimize jargon, care about business metrics, talk about simplicity, not complexity, talk about the smaller grain, not the big size, think about experience, don't solve for a transaction, integrate it into the ecosystem, invest in communicating the vision at the developer level, address the skill set and the training issue, and set expectations that you can beat. I think that's it from my side. Thank you.